Hello, BASEF Science Fair judges. My name is Isabella. I'm a grade 8 student, and I'm so excited to be sharing with you my science fair project. My project is titled Cosmic Chocolate. In my experiment, I determined if the speed of light can be calculated using a chocolate bar, the wavelengths from a microwave, and the speed of light formula. I was able to prove my hypothesis by removing the rotation plate in a microwave to make the wavelengths visible. My results showed that by measuring the distance between the hot spots on a chocolate bar, converting the microwave megahertz to hertz, then multiplying the two by each other, the speed of light on Earth is 29,400,000,000 miles per second. Finally, this is different from the speed of light in the vacuum of the space-time continuum because photonic particles move at their fastest in empty space. I spent about 1 month studying and completing my project. I completed all of my research within physics textbooks. I came up with the title Cosmic Chocolate because I am using a chocolate bar to measure a cosmic constant. I chose to use a thick 200-gram chocolate bar because I did not want the entire chocolate bar to melt, because if the chocolate bar was too thin, the wavelengths would have melted through and the heat would have spread everywhere, making it harder to determine the hot spots on a chocolate bar. Finally, I came up with my procedure of how to measure the speed of light by following light equations. I am so fascinated by the study of physics, understanding how everything in our world works, and turning scientific theories into a reality. After reading my university physics textbooks, I really enjoyed learning about Einstein's relativity, Newton's experiments in light, and learning about universal objects that travel as fast as light, such as wavelengths and neutrinos. After learning that wavelengths travel at the speed of light, I started experimenting to see if they can be used to calculate the speed of light using wavelength-producing machines such as microwaves. The challenges I faced with my experiment was, even if microwaves do produce wavelengths in certain spots, they are invisible to the unaided eye, and rotation plates allow wavelengths to spread heat evenly. I overcame those difficulties by removing the rotation plate and finding foods that melt, so the wavelengths will create visible hotspots. I enjoyed taking what I learned from physics books I read and turning them into experiments. I also really enjoyed analyzing my results and comparing the speed of light on Earth to the speed of light in the vacuum of space, because even though I read about the difference in speed and why this occurs, I was able to confirm for myself what I had read and found an efficient way to test it. I was able to experiment in my kitchen since I only needed one chocolate bar and a microwave to complete my project and assess the hotspots on a chocolate bar left by wavelengths. I was able to get support from my teachers and staff members on the science fair committee at my school. I was able to get informative books about physics recommended to me from my school library. I feel that the next step for my project would be to use another safe microwave producing machine to measure the speed of light. Possibly, if you were interested in topics related to light or physics, you could use my procedure to measure microwave wavelengths or other visible wavelengths in the electromagnetic spectrum. If you wanted to measure the speed of light, or something heavily studied in physics that moves slower in light, since sound produces light, you could measure the speed of light compared to when it is in sound. The possibilities are endless, and creativity goes a long way in science. I really hope you enjoyed listening to my science fair project. Have a wonderful day.